Hey, how we feeling? Yeah! Anyway, thank you everyone for bringing your energy to this wonderful event. You're going to learn today that this magnificent Ford Motor Company robotics building is the launching pad. This is for you, Alec. It's a launching pad for improving our ability in the College of Engineering to serve our students and live our values. It's also the culmination of a huge team effort, the fruit of tremendous passion and dedication and camaraderie. As all great efforts, this one required a spark to get it going. That spark was provided by then Associate Dean for Research, Alec Gallimore, who charged Don Tilbury with developing a vision for the robotics effort at Michigan. We saw very far. Alec and Don, on behalf of the students, staff, and faculty of the Robotics Institute, we all thank you. And with that, I give you the College of Engineering's rocket scientist, leader, visionary, and my friend, Dean Alec Gallimore.
Any questions? Greetings and good afternoon to those of you who are joining us in person and many others who are viewing us via live stream. Let me first offer a special greetings to some distinguished guests with us today. I'll ask that we hold our applause until all names have been called. Please stand briefly or wave to be recognized. U.S. Congresswoman Debbie Dingell of the 12th District of Michigan. The Regents of the University of Michigan, starting with Jordan Acker, who's the chair. Paul Brown is on his way. He may not be here yet, but if he is, he's going to be sitting next to Sarah Hubbard. Michigan Economic Development Corporation CEO, Quentin Messer. University leaders, President Schlissel. Vice President for Government Relations, Chris Kolb. And of course, our deans. Jonathan Massey, Dean of the Taubman College of Architecture and Urban Planning. Laurie McCauley, School of Dentistry Dean. Elizabeth Moji, Dean of the School of Education. And Lori Plout Snyder, School of Kinesiology. Countless entities and individuals have labored and sacrificed to make this incredible vision of robotics come to life. Ron and Regina McNeil deserve special praise. The McNeils are dedicated supporters of the University of Michigan. Ron actively participates on our Michigan Engineering Diversity, Equity, and Inclusion Advisory Council. Regina is a strong advocate for Detroit partnerships through the School of Education's Dean Advisory Council. Together, they mentor Michigan engineering students, hosting dinners and challenging young people to push outside of their comfort zones. As a result of their dedication, they have earned the university's Hermelin Award for fundraising volunteer leadership. Their wonderful generosity has contributed in many ways to the university's progress. Here, they have made possible the Ronald D. and Regina C. McNeil Walking Robotics Laboratory. It's a world-class laboratory for developing and testing legged robots. We appreciate the tremendous resource this space offers to our faculty, staff, and students. We are proud that the work to be done there will aid people well beyond our campus, from first responders in disaster relief to survivors of physical trauma through improved prosthetics. And we expect to have another announcement about a significant additional commitment for Michigan robotics support to share in the near future. Regina and Ron, thank you for your commitment to the University of Michigan and to the common good. Also, in his absence, we wish to thank for his generous support of this project, Pete Werman, Director of Sony's AI office and recipient of the 2020 Mechanical Engineering Department Alumni Merit Award. Pete earned graduate degrees here in both computer science and engineering and mechanical engineering. Several members of Michigan Engineering's Leadership Advisory Board are with us today, in person and remotely. One of those members has been a long-standing executive champion for us at Northrop Grumman. That partnership has included corporate support for another of our robotics-based facilities, Acker, which is next door, that large netted facility for our drone testing. Thank you, Ruth Bishop, for your support of our robotics work. Thank you, everyone, for joining us today. We are sincerely grateful to our partners in this enterprise and in so many other endeavors for years across the campus, especially Ford Motor Company. We will hear from a Ford representative shortly. But today, we celebrate a future of remarkable research with breakthrough potential born of intellectual curiosity. I'm equally excited that this venture embodies the equity-centered engineering ethos we are creating throughout Michigan engineering. Thank you to Jessy, Chad Jenkins, and the entire robotics community for advancing imaginative new possibilities. Now, as we continue our program, it is my pleasure to introduce the chair of the University of Michigan Board of Regents, Regent Jordan Acker.
Thank you, Dean Gallimore, and thank you for your inspiring leadership. Before I get started, I'd like to first acknowledge my colleagues who are here. You don't have to hold your applause this time. I'll start with Regent Paul Brown, who is in the back there, who lives right here in Ann Arbor, but he wanted me to tell everyone he's from Petoskey. And Regent Sarah Hubbard, one of our newest colleagues, who's from Okemos. As many of you know, there is a legend, a myth, that there is a Michigan flag on the moon. There is no actual Michigan flag on the moon, but we as a university plant our flag here today, opening a new frontier of scientific discovery. The university that helped power the Apollo program, that steers the future of self-driving cars, is working with the company that pioneered automation to ensure the future of that industry and many others are built right here in Michigan. Indeed, it is the future of Michigan, high-paying jobs, new industries, and new ideas that will be engineered right here in this building. I know I could speak for all of my colleagues on the Board of Regents when I say we couldn't be thrilled with this new frontier that we're exploring, not on the moon, but right here on North Campus. And now I'd like to introduce one of the leaders who helped make this happen, the 14th President of the University of Michigan, Mark Schlissel.
Thanks very much, Regent Acker. I want to say hi to the gallery. Everybody notice those students upstairs, great spot. And I'm really delighted to help celebrate the dedication of the Ford Motor Company Robotics Building. I want to thank our great partner, Ford, and recognize Jim Bukowski, a Michigan alum and Ford's Interim Vice President of Research and Advanced Engineering, who's here today. It's always great to see Congresswoman Dingell, and is the Lieutenant Governor here yet? He was supposed to join us today. Oh, it would have been great to see the Lieutenant Governor as well, but Congresswoman Dingell is just an incredible supporter of the university, and it seems as if she has the ability to be in many places at the same time. So we thank her for having one of her presences here. Our partnership with Ford Motor is exceptional in every way. For more than 60 years, Ford's been a tremendous supporter of the university, of our research, and of our students. In fact, Ford is our most generous corporate donor and corporate research sponsor. This alliance has been a model for university-industry collaboration. Ford has supported almost 50 units on our Dearborn and Ann Arbor campuses, and U of M is Ford's top university for recruits. U of M research and education are strengthened by collaborations with industry, helping us advance our mission while also powering the economic prosperity of our state. Ford values collaboration as much as we do. More than 100 Ford engineers and researchers are permanent residents on the 4th floor, where they'll perform robotics research and engineering with U of M and other industry leaders. We have not done this before. This is the first really university private sector collaborative building in our university's 200-year history. This one-of-a-kind building serves as the hub of U of M's Robotics Institute, allowing researchers from all across the campus to work on robotics in one state-of-the-art place. Researchers who used to reside in 23 buildings and 10 top 10 U of M programs come together right here. They develop roboticists and robotics for medicine, human health, and transportation. I had the privilege of taking a tour. Dean Gallimore and Jessy and other colleagues gave me a tour of this facility a couple of months ago. I got to go to the test lab for drones. I was actually fitted with assisted robotic devices on my feet to help me be able to march further and stronger and up bigger hills and jump tall buildings. I got to see wonderful teaching labs where students will get to assemble robots as part of their course work. And also I learned about the purposeful efforts Michigan Engineering is making to bring diversity to the field of engineering. You know, there's talent everywhere, but in the profession of engineering, diversity has lagged, not here at the University of Michigan. That gives us yet another advantage beyond a beautiful building, a breadth of people and a breadth of talent that comes from more different places in our society than most every other institution. And that's a real advantage and something I respect a lot. I'm old enough to remember when science inspired wonder and awe in our society. Being back here reminds us just how far we can reach when we work together to advance human potential. It's a place where robots walk, imaginations soar, and our students learn to lead. The work here joins with the mobility research our faculty conducts at MAIR, MCity, and the Friedman Marine Hydrodynamics Laboratory. With this facility, the University of Michigan becomes the only academic institution with test facilities for robots on land, in air, in water, and in space. We look forward to seeing the exciting innovations in mobility that will come from this remarkable facility. Thank you very much, and I'll turn it back over to Dean Gallimore.
Thank you, Regent Acker and President Schlissel. And I just want to acknowledge, and you have a witness, that no presidents were harmed when we gave the tour of the robotics building back on the 13th of May. Now, I am pleased to introduce Director of Controls and Automated Systems at Ford Research and Advanced Engineering, Craig Stevens.
Thank you very much. And thank you for giving me an excuse after 18 months in a shorts and t-shirt to get my tie out. So I am incredibly proud to be here today representing the Ford team and really opening up this building for its true intended purpose. Within the Ford Motor Company, my area of responsibility is all our research into controls and automated systems. That includes everything from powertrain controls, where I first met Jessy Grizzle, to automated driving and robotics. So my team is really about the automation of repetitive, difficult, or dangerous tasks, and that deliver exciting new products and features to our customers. Advances in controls and software are at the very heart of the things that we do. And so robotics is interesting and important because it brings together hardware, software, and controls in new and innovative ways to create exciting systems. But this is not a new thing for Ford. We've had robots in our plants for more than 3 decades now. But in this first age of robotics, we deliberately designed things to keep robots and people separate to ensure safety. In the new age of robotics, we need robots and automation to collaborate with people, whether that be in a robotic arm in an assembly plant, whether that be an autonomous vehicle picking up a passenger, or whether that be a package delivery robot. Now, Ford has got research engineers all over the world, but it only has one on a university campus, and it's right here, and that's the Ford Robotics building at the University of Michigan. This is a pretty big day for Ford Motor Company. And thanks to our collaboration with the University of Michigan, we have the first ever arrangement where we will embed 100 Ford researchers and engineers alongside faculty and students. So we're not just improving what it means to drive a Ford, but we're improving what drives Ford Motor Company. So it'll be easy then, and particularly because I'm an engineer, to focus my remarks about all the exciting tech that's going on in this building and what's going to happen in the future. I could get excited about the robot playground, the Mars yard, autonomous vehicles, the atrium for testing drones, and my good friend Digit. But actually, I want to focus my remarks on the most important aspect of this building, and that's about connections. The first connection actually is the Michigan Avenue corridor. And if you haven't heard about it, this is going to be a place where we're going to reinvent the future of mobility. It connects the Detroit Corktown neighborhood through Dearborn out here to Ann Arbor, and it's going to be one of the first stories about really enabling mobility for society. But we're also connecting communities that are too often shut out of these kinds of opportunities. It's no secret that we need to diversify the talent pool in engineering and technology. The more diverse our teams are at the beginning of a project, the better the end solution. That's why we're excited about this groundbreaking robotics program that Jessy, Grizzle, Chad Jenkins have architected with all of the faculty. We are super excited to partner with them on that. And that's why we're also looking at other areas where we can expand robotics into other fields that are going to provide societal impacts. Ford Motor Company isn't just about building great cars, trucks, and mobility experiences. We're building pipelines to connect more communities with better opportunities. The other connection here created in this building is about the connection between robots and humanity. People have understandable anxieties about robotics and robots. It's about their safety, but more of it, we're afraid of being made obsolete. Not just our jobs, but ourselves, in a rush for technological innovations that are just being done for innovation's sake. But technology is meaningless if it replaces people. Its only purpose is to help people, and we believe that robotics is uniquely situated to amplify people's strengths, help them become faster, smarter, safer, and at whatever they choose to do. But it's not enough to build robots capable of delivering packages from autonomous vehicles. They must also become accepted parts of our neighborhoods and our workplaces and our universities and our schools. As you tour the building today, you're going to see a variety of robot projects. And what I think you may be surprised about is just how complementary many of those are going to be to our way of life. Having industry and academia partner together in this way is going to be fabulous in accelerating and bringing some of these things to our world sooner rather than later. The growth of robotics over the last decade is already making people's lives better. We see this in our manufacturing plants. We see it in the growth of automated driving technologies that you can buy today in our vehicles, and we see it now in moving goods, perhaps accelerated even more than we expected over the last 18 months. In this way, what we learn here can not only guide our acceptance of robots, but also connect us to our own humanity. And we need to remember that we bring our history and we bring our biases to any field that we work in. As we develop the future, we have an opportunity to redesign how we do things, program in all the very best things that make us great, whilst not recoding our errors. The Ford Robotics building is an opportunity for us to be better, to build better solutions, and to create a more equitable, inclusive future for us all. This building connects us with the possibility of that future, and we are super excited to work with the staff, the students, and the faculty to achieve a greater vision of humanity with robotics. Thank you so much for giving Ford Motor Company this opportunity.
Thank you, Craig. In our mission statement, we talk about Michigan engineering providing scientific and technological leadership in service to the common good. But in some respect, the line that I like the most is producing intellectually curious and socially conscious minds. That's what drives us day to day. And if anything, having our students, having our learners back on campus reminds us of why we're here. So we have 11,000 students in the College of Engineering, and I'd like to take this opportunity to introduce Andrea Sipos, who's one of those 11,000 students, one of those intellectually curious, socially conscious minds who's studying robotics for her PhD. Andrea?
Good afternoon. My name is Andrea Sipos, and I am a second-year PhD student in the Manipulation and Machine Intelligence Laboratory under the mentorship of Professor Nima Fazeli. In our lab, we focus on complex physical interactions between robots and their environments. We are fascinated by the idea of giving robots the ability to reason over touch while performing manipulation tasks, and are very excited about the future implications of our work. We envision applications in domains ranging from assistive and personal care robotics to autonomous assembly and repair operations. My motivation for doing robotics research like this is twofold and very simple. First and foremost, I want to work in a field that allows me to make a positive change in the world. Second, robots are awesome, and my inner child high-fives me every time I come to work, excited that this is what I get to do for a living. I chose the University of Michigan's Robotics Institute because the program's values of excellence, respect, and inclusion mirror my own. The students, faculty, and staff here not only dream of creating a brighter future, but expect that we will play an active role in delivering it. We are curious, we are eager, and we are dedicated to bringing our wildest ideas into reality. I am delighted to share that the Ford Motor Company Robotics Building not only allows for this phenomenal culture, but facilitates it. We can collaborate more frequently and more organically than ever before. It is nearly impossible to walk through this building without seeing roboticists and their robots out and about. Most importantly, this new space is highly accessible to stakeholders outside our program. We know that outside these doors, there are millions of people whose lives will improve because of the work we do, and we are so excited to share our progress with them. For example, the Ford Robotics Building was recently featured in a video filmed by disability activists Shane and Hannah Burkaw during their visit as guest speakers for a colloquium on assistive devices. This event, which I organized with other members of the Robotics Graduate Student Council, was a runaway success. The outpouring of interest and support in response to Shane and Hannah's video, which received 140,000 views, reminded us that when we're around such diverse and incredible colleagues all day, every day, it can be easy to take for granted just how remarkable our work is. As one viewer shared, I am not tech savvy at all, and I was just in awe at what robotics can accomplish. The disability community has so much to look forward to now and in the future. We at Michigan Robotics are at the forefront of robotics research, and it is our duty to be mindful in our work, provide enthusiastic outreach, and have integrity while shaping the future. We are so grateful for the support of everyone here, and we cannot wait to show you what we can do for years to come. Thank you.
Thank you, Andrea. I'm now delighted to bring forward a visionary. Along with Jessy Grizzle, he's shaping the curriculum and culture of robotics in a way that has potential to transform engineering education. Please welcome Associate Director for Michigan Robotics, Professor Chad Jenkins.
Masks are important. So hi, thank you for that great introduction. So I am Professor Chad Jenkins, Associate Director of Michigan Robotics in charge of the undergraduate program. I'm also the leader of the Laboratory for Perceptive Robotics and Grounded Reasoning Systems, or the Laboratory for Progress. It is excellent to be with you here today in this amazing building to start a new journey together in the Ford Motor Company Robotics Building. Just take a look around. Really you should just take a moment, breathe it in, feel the spirit of this building. There's just an overwhelming sense that we get every day that that we really have something special. We're really doing something special here. There really is, there is really no other building like this on the planet. I could think of no other place that brings together a global community of scholars from all corners of the world that advances the full spectrum of robotics under one roof. Where else can you go where you can see teams of drones alongside walking robots doing amazing things? Where else can you go where you can have a garage where there's underwater robots sitting next to autonomous cars? Where else can you go where you have systems that are poised to improve the human condition, where they enhance physical performance? They're able to augment the human body. They're able to draw upon ideas from biology and contribute back to biology, and also work on earning the trust and confidence of humans and people in society, where we're thinking about new ways of manufacturing and building the products of the future, where we have robot arms that are capable of handling the diversity, dexterously handling the diversity of objects in our world, and mobile manipulation robots that can go deliver snacks to hardworking students all across campus 24/7, 365. And maybe with the help of our partners at Ford, we can go deliver it to their house. We can have a robot just drop in and say, here, you're studying, here's something special for you to help you along. And as a son of Southeast Texas, Jefferson County in Southeast Texas, being here is beyond my wildest dreams. I never thought this would be possible. And it really makes the sacrifices of those who came before me that much more appreciated and that much more special to me personally. For this opportunity, we owe a tremendous debt to the College of Engineering, to the University of Michigan for taking this daring step to move forward with robotics, to tread where others have hesitated to venture. We are deeply grateful to Ford Motor Company, the McNeil family, and the many benefactors who have made the dream of this building a reality. Thank you for joining us for this momentous occasion. Thank you for giving us this platform to make the world a better place. Moments like this are special and really only come along once in a career, maybe even once in a lifetime. And I'm not just speaking of this new building and our great people. It's also about the values that we have in Michigan Robotics that we carry out every day. And these values are summed up in one phrase: robotics with respect. Robotics with respect is about making the values of equity and excellence top priorities in everything we do. These are not just words, these are things that we live every day. We live it out in our scholarship, our classrooms, our research labs, our partnership, our outreach, and our impact on society. And now more than ever, it's evident that our work here at Michigan is not simply an academic endeavor, it has a real effect on the world, where both equity and excellence is critical for our future prosperity and sustainability as a society. As robotics takes shape as a discipline, we have the opportunity to do robotics the right way. Michigan Robotics has the unique opportunity to define the discipline of robotics and serve as a model for equity and excellence. Together in this building, we will educate the leaders and the best innovators, opinion makers, contributors, and excellent people in this burgeoning robotics ecosystem. We will develop the ideas and insights that will bring the robotics of our dreams into the reality of our future. We will stand together to ensure that everyone across zip codes, time zones, and walks of life have access to everything robotics has to offer. We will make robotics with respect. Not just the values of Michigan Robotics, but the calling of our field. So together, I encourage you to join us in this mission and North Campus represent. Thank you very much.
So every time I hear Chad speak, I always have to say, I want what he's having. Maybe from the Eigen Cafe there. Maybe we'll get a little robot delivery going on. Thank you, Chad. Well, the speaking portion of our program is now concluded. Now we will proceed with our dedication photo. As the building is already open, and then because it represents new approaches in many ways, we're not having a traditional ribbon cutting ceremony, and there will be no scissors-toting robots today, I promise you that. Rather, we are pleased to present each of today's speakers with one of our beautiful mementos. Then we will take our photo immediately following. I encourage everyone to take this wonderful opportunity to explore this amazing facility. Members of the robotics community are stationed on each floor to help guide you. All 4 floors are available for touring. We thank Ford for their collaboration providing access to their 4th floor space. For those of you viewing remotely, a virtual tour will begin shortly. In-person tours will conclude at 4:30. At that time, those of you here are invited to join us for a reception back here in the atrium. Enjoy your afternoon, and would the following individuals, after ensuring that your masks are securely on your faces, please join me in the front of the stage. Regent Acker, President Schlissel, Craig Stevens, Jessy Grizzle, Chad Jenkins, Andrea Sipos, and of course, Ron McNeil. Thank you.
Good morning. Yes, I am Jessy Grizzle, and I get to build robots while training tomorrow's roboticist. I'm also professor of electrical and computer engineering and director of the University of Michigan's Robotics Institute. Even though I'm director, I'm just a small part of how awesome this community is. I'm so thankful that we now have an equally awesome facility to work in. Let me show you. This is our community's new home. Faculty members from 23 buildings and 10 top 10 programs will be able to work together under one roof to drive the entire field of robotics toward a future that puts people and not just technology first. In 134,000 square feet, experts in how robots sense, reason, and act will be just down the hall from one another instead of across campus. The building has state-of-the-art classrooms, but what really sets it apart are the collaborative labs and workspaces. In the 3-story fly zone, we'll be able to test autonomous aerial systems indoors. It's outfitted with high-speed motion cameras to help translate a drone's movements into the math required to improve upon their capabilities. Next door in the Ronald and Regina McNeil Walking Robotics Laboratory, we will drive the evolution of walking robots, things like bipeds, quadrupeds, and powered exoskeletons. The centerpiece is a colossal in-ground treadmill. Because leg robots and exoskeletons could one day aid in disaster response, they'll need to be able to avoid obstacles and move fast across rough terrain. We can crank this baby up to 30 miles per hour, inflict steep grades, and even stick obstacles onto the belt. Around the corner, researchers in the rehabilitation lab will create advanced prostheses and show how robotics can help people who are living with limb loss. They'll be aided by the lab's multifunction floor, which includes a 2-track treadmill, force plates, and what can be thought of as an earthquake platform. This can tilt in any direction to test how prostheses react to unexpected forces. When researchers are ready to push their robots onto greater challenges, they can take them outside to an area designed with the aid of artificial intelligence. Robotics PhD student Alexander Carlson and architecture professor Matias Del Campo fed a neural network a massive cache of satellite images that resulted in terrain that tests robots in a variety of settings. All of this is done under the eye of motion capture cameras. Bigger wheeled robots, like self-driving cars, can pull right inside one of our 4 high bay garages. The experts in LiDAR and human-robot interaction can explore how to make self-driving technology safe and inclusive. These bays are just a mile down the road from M-City, our mock Main Street proving ground for autonomous vehicles. If your autonomous vehicle isn't meant for Earth, you can try it out on the Mars yard. This testing site mimics the red planet's soil character and composition, built with input from U of M planetary scientists and NASA. Now, our Mars rover student team can create a robot in the new 2,600 square foot makerspace using the CNCs, 3D printers, laser cutters, shop tools, and soldering equipment, and test it just steps away. This is only a glimpse into what the Ford Motor Company Robotics building will enable. This is a truly dazzling facility full of some of the most advanced research and teaching infrastructure in the world. But what I'm personally most excited about is the people it will bring together, including our collaborators at Ford, and what we will all be able to accomplish collectively. We look forward to showing you as we settle in. I'll turn it over now to Mario, who will walk you through Ford's dedicated space.
Thank you, Jesse, and good morning. My name is Mario Santillo, and I lead the robotics research team at Ford Motor Company. I got my master's and PhD in aerospace engineering here at the University of Michigan, so I guess that makes me a rocket scientist. I used to work in the aerospace industry designing satellites, basically space robots. But since you can't put your hands on satellites, you rely heavily on simulation and computer models. But really, they're not so different from robots right here on Earth. At Ford, even though we can be more hands-on with our robots, we may deploy them in faraway places. So they may as well be in space, and they need to be designed for independence. Since robotics is moving at such an unprecedented pace, Ford Motor Company partnered with the University of Michigan for this new robotics building. By mixing academics and engineers together in the same facility, we can benefit from researchers of all different backgrounds working together. And that accelerates advancement to practical applications, whether it's a walking dog robot named Fluffy that's used in manufacturing, or a driverless car that could revolutionize transportation. When researchers from both industry and academia are housed in the same facility, we can advance robotics more quickly. One day, a student can be learning about robotics theory in a classroom, and the next day, working hand in hand with Ford roboticists. By fostering these closer relationships with world-class faculty and students, we can find new ways to work and accelerate the creation of new robotics applications. The first thing I tell people about the Ford Robotics building is about the space, just the wide open lab spaces. Robotics is interdisciplinary and draws a diverse crowd. And these open lab spaces encourage greater interaction through a nice mix of we space and me space. The Ford Robotics building is also a Disneyland for robots. There's a 3-story indoor drone fly area, a giant treadmill for robots, even an outdoor robotics playground. And all of this is because we're increasingly seeing robots do useful work for society. Our presence here alongside the University of Michigan allows us to be on the leading edge of this trend. The Ford team is applying robotics to real-world situations. We're taking world-class theories and asking, can we really do this? We will accelerate advancement in the lab to create valuable products and services and put those applications to market more quickly so everyone can benefit.